Okay. So good morning friends. My name is Ruturaj and today we are going to start a subject engineering mathematics. In this we will start our first chapter, that is linear differential equation. Okay. So I will write here linear differential equation. So now what is linear differential equation? So in our lower standards we have acquainted about the differential equation, but now this is linear differential equation. So I will write an example. So any equation, any differential equation in the format this. This is our ADE, that is linear differential equation, where Pn, P1, P0 are constant and my x is any function containing only one variable, that is x. Okay. So now to write a general solution of this linear differential equation, we need to first calculate a compact form and a particular integral. And to find the compact form, we must write an auxiliary equation. So for this, what will be my auxiliary equation? So for writing auxiliary equation, we need to replace dy by dx with d, capital D into y. Likewise, d raised to n upon y whole divided by dx raised to n with d raised to n into y. Okay, so we replace this equation with this, and so we can write this also equation also like d raised to n into y plus dot 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 p1 dy plus y equals x. Okay, so I can also write this equation in this format. This is also correct. Now for writing an auxiliary equation, I must replace all the d's with m and equate this RHS with 0. Okay, so my auxiliary equation will be Pn m raised to n plus dot 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 P1 m plus 1 equals 0. Okay, and on depending of these roots of m, depending the values of m, we write a compact form. So now let us discuss what are the rules of writing a compact form. Okay, yes. Okay, now I am writing here rules for compact form. Okay, so consider that my auxiliary equation roots are, there are two roots of my auxiliary equation and they are real, okay, but not equal. Okay, so consider I am having the roots m1 and m2. So my compact form will be written as c1 e raised to m1x plus c2 e raised to m2x. Now what is c1 and c2? So c1 and c2 are the two constants. So for this, now I am having the two roots which are not equal and they are real. So my auxiliary equation would be a polynomial with a degree 2. Okay. Next, now I am having three roots. Consider three roots. All three are real and two of them are common, means two of them are same. So consider that they are m, and m1. Okay, this is my 1. Yes. So now for this we need to write of compact form as like this. It can be C1 plus C2x whole into e raised to mx plus C3 e raised to m1 x. Okay, so now this was a common root, so I wrote c1 plus c2x. Now if there are three common roots, then I also need to add one more term in this, that is c1 plus c2x plus c3x square. Okay, now consider I am having a imaginary roots. Okay, so they can be a plus minus ib. Always remember, when there are imaginary roots of an equation, then they always exist in a conjugate form. Okay, so if a plus ib is one of my root of my equation, then a minus ib is also one of the root, which is imaginary. Now to write a compact form for such equation, we will use e raised to ax into c1 cos bx plus c2 sin bx. Okay, this is for both the conjugate square. This is my solution. Now consider I am having a imaginary roots which are also repeated. Okay, so they can be a plus minus ib and again a plus minus ib. So my total number of imaginary roots are 4, 2 here and 2 here, and they are also repeated. So now my compact form will contain like this: e raised to ax in bracket c1 plus c2x whole into cos of bx plus c1 c2 c3 plus c4x into sin bx. Okay, so what we understand from all this is that the number of roots, they might be real or imaginary, is equal to the number of constants in our compact form. Here are my two roots, so there are two constants, that is c1 and c2. Here are my three roots, so there are three constants, c1, c2 and c3. Here are my two roots, so there are also two constants, that is c1, c2. And here there are four roots, so there are four constants, that is c1, c2, c3 and c4. Okay, so now we will discuss further how to write a particular integral in our next lecture. But in this lecture we will discuss on the homogeneous equations. Now what are the homogeneous equations? So as you had seen that in previous one slide, I had wrote that x is the function of one variable, that is x, so that capital X. So when that RHS is equal to 0, then we call that equation as our homogeneous linear differential equation. Okay, so in today's session we will solve some numericals based on that. Okay, I will wrap all this. Yes. So I will just find the questions. Where are my questions? Yes. So my first question is d cube y upon dx cube minus 13 dy by dx plus 12y equals 0. So now this is my homogeneous equation. So it is a point to be noted that for homogeneous equation, my general solution will be equal to compact form, because particular integral will be 0. Okay, now we will discuss in further lecture what is particular integral, but let's focus currently on this. So our first step is to replace this dy by dx with d into y. So this term will be rewritten as d cube into y minus 13 into dy plus 12y equals 0. So I can also write this as d cube minus 13d plus 12 whole into y equals 0. Now this turns out to be my f of d. Now writing an auxiliary equation, okay, my auxiliary equation will be replacing the d with m. So m cube plus 0m square minus 13m plus 12 equals 0. Now why I have written 0m square? Because m square, a square term is missing from this polynomial, and for the precaution measure to avoid mistakes, I have written 0 into m square, which is 0. Okay, so now we need to calculate this roots, that are m and n. So I will make use of our scientific calculator to calculate these roots. Okay, so just a second, I will just calculate this. 1, 0, minus 13, and this is 12. Okay, so my answer turns about to be m. I will purposefully writing it below. I will just tell you the reason sometime. M is 1 minus 4 and 3. Now if I write this equation and directly final answer, then I won't get any marks in exams, because steps are necessary. So it's a trick that you calculate answer with this and then write like this. So I know that these are my roots, so I can also write this as m minus 1 into m plus 4 into m minus 3. Now you can see that I just changed the sign of those roots and wrote it in this form. Now I can also write this as m minus 1 into, now I will multiply these two things. It will be m square plus 4m minus 3m minus 3 4s are 12 equals 0. Just a second. Yes, correct. It's absolutely correct. So this will be m plus 1. Excuse me. M minus 1 into m square plus m minus 12 equals 0. Now you might wonder that this turns out to be minus 12 and this was plus 12. But the reason why this is correct, because I take my m minus 1 from common from these all terms. So this sign change, if you multiply these two, then I will get this only. So there is no mistake in this. It's absolutely correct. Now I have three roots which are real and distinct. So my compact form will be like c1 e raised to 1 into x plus c2 e raised to minus 4 into x plus c3 e raised to 3 into x. Okay, so now this is my compact form. Now I will write a general solution which is to be written like this: y of x is equal to compact form plus particular integral, but my particular integral is 0. So my general solution would be like y, which is a function of x, turns out to be c1 e raised to x plus c2 e raised to minus 4x plus c3 e raised to 3 into x. Okay, so this was one of the most simple questions from this chapter. You may note this. Yes. Okay, amazing. I will rub this. Now we will move on for the next question. Okay. moving for the next question, which is question number 2, which is yes, d square y by dx square, sorry for my handwriting, minus 6 dy by dx plus 9y equals 0. Okay, so I will now directly write auxiliary equation for this question. My auxiliary equation will be m square minus 6m plus 9 turns out to be 0. Now if you see this neatly, then this is nothing but m minus 3 the whole square, which is equal to 0. Okay, so from this we get our roots as m equals 3 comma 3. Now here we find that there are two real roots which are same. So now compact form for this will be as follows: c1 plus c2x whole into e raised to 3x. Now my general solution will be ZHES is equal to compact form plus particular integral. But as this equation is a homogeneous equation, my particular integral will be 0, and my general solution, which is y, which is a function of x, will turn out to be c1 plus c2x into e raised to 3 into x. Okay, so this is my final answer. Please note this down, then we will move on for the next question. Yes, I will grab all this stuff now. Okay, so next question, that is my question number 3, which is d cube y by dx cube minus 5d square y by dx square plus 8 dy by dx minus 4y equals 0. Now I will also write, now I need to write the auxiliary equation directly for this. So my aux equation is d cube, sorry, d no, m is m cube minus 5m square plus 8m minus 4 turns out to be 0. Okay, so now solution for this equation, I will just calculate it through my calc. Okay, so now I have got the three roots. My m turns out to be 1 comma 2 comma, okay, so this root is being repeated. Okay, yes. So now again we need to reverse write this to prevent reduction in our marks. Okay, it turns out to be 0. Yes, yes, yes. So this turns out to be m minus 1 into, this is square of m minus 2, m square minus 4m plus 4 equals 0. Okay, so this is absolutely correct, I guess. Yes, 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 yes. Now let us discuss the compact form. So my compact form will be, there are two same roots. My compact form will be c1 e raised to x plus c2 plus c3x into e raised to 2 into x. So my general solution, which is nothing but my compact form only, will be c1 e raised to x plus c2 plus c3x into e raised to 2 into x. Okay, so this is my final answer. You can note this down. I will rub all this stuff now. Okay, so moving on for our last question, that is fourth question, which is d square by dx square plus 4 dy by dx plus 5y equals 0. Okay, so now I request you all to stop the video and solve this answer and recheck it with your own answer. Okay, so solve this by yourself. I will just solve it and show you. So I am directly writing my auxiliary form, which is d square plus 4d plus 5, which turns out to be 0. Now using calci I will calculate what are the roots. It seems that there are complex roots for this equation. 1, 4, 5. Yes. So my d turns out to be, you can write directly for this, minus 2 plus minus I. So as I said that when there are two imaginary roots, they always come in a conjugate pair. So you can see here. Now this is one of the simple question I feel. Compact form is equal to e raised to ax. My a is minus 2. So e raised to 2x in bracket I will write here c1 cos x plus c2 sin x. Now why only x? Because this b is 1. Okay, so my general solution, which is y, which is a function of x, turns out to be e raised to minus 2x into c1 cos x plus c2 sin x. Okay, so this is my final answer for the given question. So we are stopping the session here and we will meet in next session. We will discuss the particular integral for the next session. So thank you very much for watching. Please like, share and subscribe this amazing video. Thank you.